Okay, so unit 2, day 4. We're going to still get more practice with simplifying radicals, but then we're also going to see our other special right triangle, namely the 30, 60, 90 special right triangle. So first, let's just get more practice with simplifying the radicals. So we're going to do our perfect squares again, just because it helps. Repetition helps you memorize them. So to start off, 2 squared. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 is 81. 10 is 100. 11 is 121. 12 is 144. 13 is 169. Again, my favorite too, 13 squared and 14 squared. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is, pretty sure we said 361. What did we say yesterday? I say yesterday as if I'm recording this on different days. I'm recording these all the same day. 19 squared is 361, yes. 20 squared is 400. 21, 441. 22 is 484. 23, 529. I still need to memorize that one. 529. 24 is 576. And 25 is 625. You can kind of tell based on the 2 that I haven't memorized which ones you don't really use too often. 23 squared and 19 squared. In my 28 years. Now, granted, I wasn't using these as a baby, but still, in the 12, at least 12 years, no. Probably going on 15 years that I've started dealing with squares, I still have yet to memorize 19 and 23 squared. Got them all, got all the others, just not those. Anyways, so those are our perfect squares. We're going to simplify radicals again. So A asks us to do the square root of 576. Now, if you're looking up here, you're like, wait, 576 is on the list. You're right, it is. Square root of 576 is simply 24. That's simplified. It's 24. End of story, case closed. The square root of 8. I'm going to do this one. Remember yesterday I said there were 2 ways. So I'm going to do this one the original way, the OG way. So 8, what goes into 8? Well, 4 times 2. So I break it up, square root of 4 times the square root of 2. What's the square root of 4? 2. And then 2, the square root of 2 just stays square root of 2. So 2 square root of 2 is this one. That one's simplified. 18, I'm going to do our tree. So 18, 2, and 9, of course. 9, you can break down to 3 and 3. Couples go out on a date. The single stays home. So that goes out there. This is going to be 3 square roots of 2. Couples go out on a date and become one. The single stays home. I guess I should box him in because that's really it. Okay, on D, we've got some fractions here. Remember, when you have fractions, look at the bottom. It tells you what to multiply by. Square root of 3 over the square root of 3. So on the top, we just smash them together. The bottom, you take away the bar. Now, I want to see, can I reduce 9 over 3? 9 divided by 3 is 3, and then I have the square root of 3. So 3 square roots of 3. Look at E. It's going to be the square root of 2 over the square root of 2. On top, you smash them together. On the bottom, you remove the bar. Can I simplify 5 over 2? No. Don't tell me 2.5. No, I can't. It won't be a whole number. So I'm done. If it's not going to be a whole number, I don't want it right now. Leave it as a fraction. Okay, so that's a review of simplifying radicals. The reason we reviewed it is we're still going to need them heavily today. Okay, so the main topic. We want to look at 30, 60, 90 special right triangles. So a 30, 60, 90 triangle is another type of special right triangle, and we can use an equilateral triangle to try to find its relationship between the sides. So they give us an equilateral triangle here. I want to use just half of it. I'm just interested in half. I'm going to do this half. So I want to use the Pythagorean theorem to get y. Well, remember, Pythagorean theorem, first step is get your c. There's my c. So 5 squared plus y squared equals 10 squared. 5 squared is 25 plus y squared equals 100. Subtract 25. We get y squared equals 75. Now, when I go to take this square root, I want to simplify my radical. I don't want to put it as a decimal. So I'm going to do the tree method since I have room down here. 75 is 3 and 25. 25 breaks down to 5 and 5. There's my couple. And there's the single. So y is 5 square roots of 3. That's what y is. So now, I'm going to write this right here. And I want us to look at something. What do you notice? Well, I see a 5 right there. And then I look for my y and I see a 5 there. Interesting. What is 10 equal to? What can I multiply? What two numbers can I multiply to get 10? Other than 10 and 1. I could do 2 times 5. Huh? 5s are everywhere. They're everywhere. They're everywhere. If I had to guess, I would say there's a relationship that deals with those 5s. Because they sure are everywhere for there to not be a relationship. It's like you see a couple walking down the hall at school. Every day they're always together. You always see them together. It's like, are they related? No, I know they're not related. They must be dating then, because my goodness, everywhere you look, they're together. It's gotta be a relationship. Same thing with these 5s. Everywhere you look, there's a 5. There must be a relationship. There is. So in a 30, 60, 90 triangle, the length of the hypotenuse is 2 times the length of the short leg. And the length of the longer leg is the length of the shorter leg times. They left out the square root of 3 here. Let me fix that. Okay, hang on here. Give me a radical. Now the square root of 3. There we go. It's fixed now. All is right in the world. Okay, so what that's saying is, again, think of your legs. The legs are what make the right angle. So this is a leg. This is a leg. Whoa. What's going on here, buddy? Computer's spazzing out on me. Oh, they're missing that square root of 3 too. 1 second. Okay, there we go. So those are our 2 legs. The short leg is X. The short leg is X. So short leg is X. The long leg is X square roots of 3. And then we have our hypotenuse. It's 2x. That's your relationship. Short leg is x. Long leg is x square roots of 3. Hypotenuse is 2x. Okay, so let's use this on these examples. Of course, we're going to use this on these examples. What else would we use? Okay, example A. So they want us to give that all the missing sides here. So let's see. Let's first label our legs. This is a leg. This one's a leg. Now, which leg is shorter? The bottom. I said up here the short leg is X. So this leg's got to be X. Long leg is 8x square roots of 3. Hypotenuse is 2x. Wait, why'd you put the equal sign there? Oh, I got me a little equation. I got me a baby equation. 2x equals 16. Divide by 2, and we get x equals 8. X is 8. So that means x equals 8. That means x square roots of 3 equals 8 square roots of 3. We got our answer. Once we figure out x, we can just go plug in x everywhere. So this side is 8 square roots of 3. This side is 8. Okay, let's look at B. First thing, let's label our legs. Leg. Leg. Like, how'd you know that's a leg? Well, that's what makes my right angle. Remember, the legs make the right angle. That's a leg, that's a leg. So which one's my shorter leg? That one's going to be X. This one looks shorter. He's X. This one looks longer. He's X square roots of 3. The only one I haven't labeled is my hypotenuse. That one's got to be 2x. And yes, you saw me put the equal sign. That's because I have an equation. X square roots of 3 must equal 12. So divide by the square root of 3. That means x is 12 over the square root of 3. But we're not proper, like we talked about on the front. We got to be proper. So multiply by the square root of 3 over the square root of 3. Smash them together. And remove the radical on the bottom. Now, can I reduce 12 over 3? Yes. It's going to be 4 square roots of 3. There's my x. 4 square roots of 3. There's that side. This one is going to be 2 times 4 square roots of 3. I still need that 2 there. When I plug in for x, I still need that 2 there. Well, what is 2 times 4? 2 times 4 is 8 square roots of 3. There we go. Now for the next one. Again, first step, label your legs. There's a leg, there's a leg. So which one's my short leg? And it looks to be this one over here on the left. That means the long leg is on the right and the hypotenuse is on the bottom. Okay, I like what I see here. X equals 9. There it is. X equals 9. Period. End of story. X is 9. So anywhere I see an X, I'm plugging a 9 in. 9 square roots of 3. This is going to be 2 times 9. Well, 9 square roots of 3 is done. I can't do anything to it. 2 times 9 is 18. Now he's done. Okay, so that's our notes for today. We looked at simplifying radicals again, and then the 30, 60, 90 special right triangles. So stay tuned for the guided practice.